Lesson 12. Now, yesterday we had this exact same problem in my notes. 2x plus star equal, 2x equals star plus 6. Now, yesterday I told you when we set this one up, we had 2x plus star plus 6. And what did we want to do? We wanted to add an x to both sides. Why did we want to add that x to both sides? We were trying to get the 6 by itself. Got that? We wanted the 6 by itself. Now, the reason I want the 6 by itself is if I want to get rid of the x's, in this case, instead of the stars, I could have done that. I could have added a star to both sides and a second star to both sides, star and star. So I could have added 2 stars to both sides, and then everything on the left-hand side of the balance is gone. Does that look balanced? No, everything's on one side. We don't want everything on one side. We want it to be stuff on both sides. We want it to be balanced. So that's why yesterday we tried to eliminate the star. Now, I want to show you another way that we can eliminate star. That's not what I want. I wanted the 6. Okay, there we go. Another way we can do it. As we know, a star and an x cancel each other out. A star and an x cancel each other out. If I put both of these on the left-hand side, star and x both on the left-hand side, they're going to cancel each other out. But notice now, I have a star on both sides that I can take off. Wow, I love that. Now that gives me 3x's equals 6, so x equals 2, and star would have to equal -2. So now when I plug that back in to check it, this is kind of easier to check. I know these two eliminate each other, the star and the x. So I've got 2 plus 2 equals, does it equal, that's the big question, -2 plus 6. Well, 2 plus 2 is 4, -2 plus 6, opposite sign subtract, 6 minus 2 is 4, 4 equals 4. So I can add a combination of star and x on either side, whichever one I need to, or I can add stuff to both sides. Now let's take a look at the next problem. Oh, I got junk in there yet. Okay, I've got x plus 2x plus 4 equals star. So x plus 2x plus 4 equals star. Now, if I do it under the same rules of yesterday, I probably want to get rid of that star because that's what we eliminated yesterday. Let me go ahead and set it up on here. X plus 2x plus 4 is star. Okay, well that does work. Here's the problem. I could eliminate star from my right-hand side. And if I eliminate star from my right-hand side, I've got nothing on the right-hand side. That's not balanced. I want to get it balanced. So what I can do is just like I did up on the board, I can add a star and an x on the right-hand side because they eliminate each other. I'm really not adding anything. I can add a second one, and I can add a third one. Now, why would I add 3 of them? Well, the answer's simple. On my left-hand side, right over here, I have 3 x's. With 3 x's and 3 x's on the right-hand side, my x's can be taken off. So now I got 4 stars equaling 4. Well, that means star is a 1. And if I go back to my original equation, if star is 1, that means x is a -1, and -1 plus -1 plus -1 plus 4. Question is, does that equal +1? -1, -1, -1 would be -3. -3 plus 4 is a +1, which is what star was. So what we did in this case here, instead of eliminating the star and getting everything on the left-hand side, we added a pair, and we added a second pair, and we added a third pair So that way we had these 3 x's on the one side and the 3 x's on the other side that we could, I don't know what I'm doing now. Woo! I'm going to undo whatever I did. That was wild. Okay, so these 3 x's and these 3 x's all want to eliminate each other from 2 sides because they're on both sides. I can take them off. So now I've got the 4 that. This leads me to say that star is 1 because 4 stars equaling 4, star would have to be 1, and that would mean x is -1. So when I put my x's back in and I eliminate my combos that I brought in, and back to my 1x plus 2x plus 4 equaling that. So I've got -1 plus -1 plus -1 plus 4. That's my left-hand side. My right-hand side, I got 1. So when I check that, these 3 x's give me a -3 plus 4. Gets me 1. 1 equals 1. So in this case, I eliminated the x's so I could get the 4 by itself. Whatever that lone number is, we want to get it by itself so we have stuff on both sides of the balance. Here's another one. I got 3 star plus 20. 1, 2, 3 stars. My boxes only go up to 10, so I'm going to need 2 10s. And that's going to equal an x. So I got 3 stars plus 10 plus 10 has to equal 1x. Wow. Okay, what I can do is I can do that pair thing. I got a star and an x and a star and an x. I want to put them on the right-hand side, these pairs, because the 10s are on the left. I want to eliminate whatever else is with the 10s. I got stars. So I can take the 3 stars off of the left and the 3 stars off of the right. Now I have 4 x's equaling 20. Well, that tells me x is 5. Well, if x is 5, star is -5. So now I go back to my original problem. 3 stars plus 20 equaling x. So I've got a -5 plus a -5 plus a -5 plus 20. That's my left-hand side. And on the right-hand side, I got 5. So the right-hand side is 5. -5 plus -5 plus -5 is -15. And when I add 20 to that, I get 5. 5 does equal 5. That checks out. So the trick today is you got to look a little bit more careful about which side the number's on and try to get the number isolated on one side and eliminate the stars and the x's from the other. Now, when you can do that, you can always bring in a pair, a x star pair, to come in on the side to help you out, and then eliminate them from both sides. Or like we did yesterday on the lesson 11, we can add things to the one side.